Welcome back. We are going to be doing a stacking mechanic using C Sharp. So I didn't want to do the standard one that's online where the cubes kind of move in from either side, and then as you stack them, if they stacked a little off, the rest gets cut off. So I wanted to do kind of what seems like a popular one at the moment, where an object will move from side to side, and then when you click the button, or the screen, it'll drop down onto this platform, and then you can stack them up and try to keep them from falling over. So I thought that was quite a nice one, and it's a little bit different. So I'm going to make this platform a little bit smaller. I feel it's a little bit excessive. And I created just the prep of the scene. I just used Kenny.nl's asset packs from his website. We'll try to remember to put a link to it, but it's Kenny.nl. And the scene, I've got a camera, I've got a ground plane here, I've got a spawn manager, which is just an empty game object, I've got a background, and I have a kill zone. So a quick talk about I created sorting layers, one for the platform and one for the background, so that they would always the platform would always be in front. I prefer using sorting layers as opposed to ordering layers. It's just easier to keep track of. You can give it a name and you can say, oh, these are meant to be in front, these are meant to be in the middle, and those are meant to be in the background, that kind of thing. So the background is set to background, as you can see. So, and then I created just an empty object with a box collider 2D for the kill volume, and I set it to is trigger. So for later in this video, I'm going to parent my spawn manager to my camera straight away, because when the camera moves, I want the spawn manager to move. Because as we stack, we're going to get higher and higher. We want the camera to kind of keep up with the stacking. And we want the spawn manager to be in relation to where the camera is. We don't want the spawner to stay near the start and then it just knocks our whole tower right over. So we're going to start by doing the spawning code. So we're going to go to scripts, not sprites, scripts. Jeepers, let's just find an empty slot here. Create C# script. I'm going to call this stacking spawner. There we go. Wait for it to compile, and once it's compiled, we will assign it directly to the spawn manager. Okay, I'm also going to turn off auto-generate lighting because it seems to be causing what takes some time. So I'm going to go to Window, Rendering, Light Settings, and oh wait, it's not. It's not even what? Okay, so it was. Yeah, it's auto-generating lighting is off. Okay, check. That's what it was telling me. Okay, so now that we have the script, I'm going to open up the script. Sorry, my script opened up off to the side here for some reason. Stop doing that. I keep grabbing the wrong thing. There we go. I use Visual Studio Code for my coding, so these are my extensions. I have the following. You can just pause the video and look at it. I found that these all work really nicely with Unity along with Visual Studio Community 2019, so that's what I've got. So inside here we're going to just, for the time being, remove any of the comments and remove the update. We will need the start, but we won't need any of the other stuff. So let's start by adding a few variables that we require. We're going to be using a list to keep track of all the platforms we can randomly select from. So we're going to make a serialized field, call it list of game objects. No, what am I doing there? Give it a name. Let's call it list of platforms. That's it. List of platforms is equal to new list of game objects, so that we generate the list. Now that we have the list, that is the only variable we need in here. The start, I'll show you what we're going to do in the start, but we need to create a public void. We're going to call this spawn platform. Void is because it doesn't need to return a value, so I'm just going to call it, and I'm going to feed, just tell it, when I call this function, do the following, which is what we're going to do here. So I'm going to make a throwaway variable, as I call it. It's going to be a game object. Let's call this current platform, and then we're going to say it's equal to, and then this is where we instantiate. So we don't instantiate just yet. We need to get a random object from the list. So we're going to say list of platforms dot random. No, my bad. Square brackets first. We do the random dot range inside. So random dot range. We're going to do 2 round brackets 0 because the list is never less than 0, and it is. And then what we're going to do is say list of platforms dot count -1. Now let me explain the -1. So what is it giving me grief for? Int is obsolete. Use random.range instead. Oh, sorry. My autocomplete decided to choose the first one, and I thought that Okay, so what we're doing is a list starts at 0. So if we have 5 items, it's going to go 0, 1, 2, 3, 4, 5. But the count starts at 1. So it's going to give us a 1, 2, 3, 4, 5, 6. So if you compare that side by side, you're going to already see where the problem lies. So if I randomly select from the count and it gives me 6, and then we go back to the list and it says, but you don't have an item at 6. So we're going to get an error. So we just take our list, we subtract it from 1, we subtract 1 from it. So if you look at when we hover over range, it says return a random integer number between minimum, which is inclusive, and maximum, which is exclusive. So we put the -1 to make sure that we get all of the count values correct. So that's what we're doing there. Now that we have that, we can go ahead and instantiate. And what are we instantiating? We're going to instantiate the current platform. And we're just going to instantiate it at the position of the spawner and the rotation of the spawner. That is what I want to do there. And if you want to put a debug log or whatever it is to test to see if it works, go ahead. But this will work as it stands. So all we did was create a throwaway variable called current, so we could store the platform we found, and then in the line below it, we basically just pop that in. We could have just grabbed this line of code here and just slapped. Could have just put this line of code in over here like that. But I just want to do it this way for readability, so it makes sense. You're like, oh, okay, we're instantiating a random object from the list. So it's clear, it's to the point, and it makes sense. So in order for this to spawn at the start, we're just going to copy this part of the function, the method. We're just going to call that once at the start. And then all the other times, we're going to call that after the fact. We're going to call that when we need it. So at the moment, we're going to go back to Unity, let it compile, and we're going to push play and see what happens. But before we do that, we need to actually add items to this list. So I have got a few prefabs here. They are all just from the Kenny.nl pack, the platformer pack. So I just got these 5 platforms. They are just basically set up as follows. I'm going to remove the polygon collider. I find that to be unstable, so I'm going to remove this. We're going to add, should just have box colliders, 2D, and they all have a rigid body. By default, I set it to kinematic. I don't want it to drop straight away. I want it to drop when I tell it to drop. So I set it to kinematic at the start, and the constraints are unconstrained. So it can rotate, it can move, all of that stuff. So that's it. So let's add the spawners. And the nice thing about this, I learned the other day, which is really cool. I'm going to select my spawner, and I'm going to lock my inspector here. I'm going to select the prefabs I have. I'm going to drag it on top of the list of platforms, and it will just add all of them to the list straight away, which is something cool. I used to do it one by one, and when I learned about this, I was like, okay, cool, that I'm going to keep using it. So that's it. So now that we have the list, it's going to randomly select one of these 5 items or 6 items. There we go. Do it again. Hopefully it won't select the same exact random one. There we go, different one. And if we play it one more time, it might even select the same one again. That's because that's the problem with truly random stuff. Means you might get the exact same result. So I don't want my platforms to spawn in the middle. I want them to spawn to the left, and then we're going to get them to go from left to right, then back to left, then back to right, and keep going like that. It's going to ping pong between the 2 areas. So then now that it's spawning, we are going to create a script that is going to go onto these objects, these platforms. So let's go to scripts, create a new script. Let's call this stacking platform. Let's call it that. It'll make a little more sense. We go, and then we're just going to go to our prefabs and assign it to all our platforms. So we're going to select all our platforms, go and say add component, type in stacking, and look for stacking platform. Now we've assigned it to all our platform prefabs. We can now go ahead and open up the script. Give me a second to open up my. There we go. So I have my notes open. Okay. So we are going to need the following. We're going to need both the update and the start, so we can leave those in place. We are going to create a few variables at the top here, starting with a serialized field for the speed. So we're going to make this a float. Call this platform speed, I guess. I'm going to set that by default to 0.5f. The next one is going to be a reference to the spawn manager, because we're going to need that later. So I'm going to make that a private spawn manager. It's not spawn manager, it is stacking spawner. That's it. Stacking spawner. We'll just call this spawner. Just keep it nice and simple. And then the next one we need is a reference to the camera, but we can do just standard. We'll just use a camera.main for now, just being like it's not the right way to do it, but we can go about doing it that way. We're going to go private, and we need to have a reference to the rigid body whenever we're working with physics, and we're just going to call this RB2D because it's a 2D physics. And then the last one is I want to have a boolean. This is also going to be private bool. And we're going to say on collision. So has this object collided with something? As by default it's set to false because we haven't technically collided with anything, so we don't want to. So to kind of side by side do this with Bolt. In Bolt we used a state machine. We are going to learn something called a switch statement, and for that I'm going to just create. We could use integers for that. But I'm going to show you how to create an enum. So we're going to make this a public. Actually can stay private, to be honest. Let's make this a private, and we're going to say enum. Just let it autocomplete for me. I'm going to give this a name. Call this platform states. And then inside there we're going to create the different states. So the platform is either moving or dropping, I guess. That should be enough. So we have two different states. We have moving and dropping, and we need to create a variable based on this enum. So we're going to go and say this is going to be also a private, and now call the name of your enum called platform states, and call this current. I guess current platform state. There we go. So this is going to be the current platform state that we're in. And then we'll compare that and see what happens if we are what happens if we're in each of the different states. So at the start, first we need to get a reference to our rigid body, which is on this current component. So we're just going to current game object. So we're just going to say get component 2D like that, and we're going to set the current platform state to be equal to. And it's going to be equal to not platform speed. Let's try that again. Platform. Oh wait, can I just grab this? I wonder if I can't grab it because it's private. Moving. There we go. No, it was just not auto completing. So at the start, I'm going to tell it that you're currently in the moving state. So that's all we need to do at the start. So we're getting the reference to the rigid body, and we're setting the state of the camera. And we need a reference to the actual spawner. So we're going to type in spawner is equal to, and we're now going to find an object by type, and it is called stacking spawner. There we go. So now that we have a reference to that script, we can now talk to that script directly through the spawner variable. That is it for now. So we're going to start by getting the object to change states and to drop. So we're going to, inside of our if update, we're going to have an if statement. We're going to say if, and we say input dot get mouse button down, Which mouse button? 0. So if we're pressing the left mouse button down, if you want to do a touch screen, you could do like touch and then the number touch.0, whatever it is that you're looking for, but we're just doing this for the PC. So if input.get mouse button down, you could also use the new input system for this. I'm just keeping until I can see how to get Bolt to speak to the new input system. I'm going to keep using this one with as far as my tutorials, but I do enjoy using the new input system a lot, so I'd definitely get you guys to take a look at that. Go for it and try it out and see if you like it. It's very cool. Okay, so if that's true, all we're going to do is grab this line here, copy it, paste it in there, and we're just going to change this to dropping. So when we press that button, we want to change the state to dropping. So what are we actually doing in each of these states? We're going to have a switch statement. So outside of here, we're going to type in switch, let it again autocomplete. We can use the default. I'll leave the default in there for now, but what needs to go inside here? We need to grab our current platform value. So we're going to say, take a look at our current platform state, and if our current platform state is, let's type in case and now we'll need to have platform states. So we're going to type in platform states dot moving. So if it is currently set to platform states dot moving, we're going to do something. You need to use the 2 dots, not the semicolon. There we go. And then we're going to do a break after that. Each of these needs a break to get out of this different state. So this is kind of, let's remove the default really. We don't need it right now. Default is in case none of these states come back true, you have a default state to fall back on. So this is what a case statement looks like. This is one of your one if statement. We're going to duplicate that. And we're going to type in dropping for this one. And now we have our two situations set up here. So this one is for when we're object is moving side to side. And then this one down here is when the object drops. That's it. So those are our two different situations that we're in. That is how that works. We have our object dropping over here, we have our object moving up here, and inside here is where we do the actual code. So let's do the actual code here. So over here we want to move the object, so we're going to say transform.position, because we want to move its position, is equal to, and we need a new vector 3, because all I care about is the y position of the movement. I don't care about the x and the z, because the x and z are going to come directly from the actual spawner. Sorry, the actual platform itself. So I don't, not too bothered, to be completely honest with that. So we're going to leave that as it is. So what we need to do is we're going to interpolate like we've done in the past videos. I don't like just having something move very snappy. It's good for prototyping, it's fine, but when you want to have a nice smooth movement. So the first section is the hardest part. So we're going to type in mathf.lerp. We're lerping between two values. I'm going to put in these values and I'll show you where I'm getting them from. The first one is minus 10, comma 10. And then the last one is the time. So we're going to go comma. And the time, I'm going to use another math function. And it's called ping pong. Because it says exactly what it does. It's like watching a tennis match or a table tennis match. It's going to imagine the ball going from left to right the whole time. That's all this animation, this ping pong does, is moves an object from side to side between. And if you use it with a lerp, it's going to go between the values we have set. So ping pong is a weird kind of thing. It took me a little bit to understand. The ping pong requires a value, like a speed value, and then it also requires kind of like almost like it says t, but I don't think it's it is time, but I think it's like based on like how fast or how slow it's going to work. But the only value in there that ever worked for me up to this point is 1. So in the first section we're going to go time.time. We're going to multiply that by we do have a speed value. I think we created one. Platform speed, yes, we did. We're going to multiply that by platform speed. That's how fast. We're using time.time because time.delta time is a different kind of time. It's the amount of time it takes between frames, that kind of thing. So time.time is the moment you start the game, it starts to record how long you've been in the game. And we're using this time value to multiply it by the speed value so we can decide how long it takes to go from side to side. So the speed value, if it's set to 1, it's going to play at normal speed, normal time over the period of the time of the game. But if you multiply that by 0.5 like we're doing, it's going to be going essentially at half the speed. So 0, 1, that is the next value. It is the float length. So I assume that in the past when I used this, it was, I think it's a normalized value, so it's probably between 0 and 1, or maybe minus 1 and 1. And I try to put the speed in there initially, and it kind of broke things. So I think you'll be fine if your value is anywhere between -1 and 1, but don't go any greater than that, or you're going to get some weird results. That's all I'm saying. So now that we've done our mathf.loop, we're putting in everything over there. All we need to do at the end between the last two curly braces is go comma, transform.position.x, y. What am I doing? I've put this in the wrong place. My bad. No, I put it in the right position. Sorry. And then transform.position.z. And execute that line of code. And that should now get it to move from side to side. Let's see if that part of the code works, and then I'll show you. When we click the state, if I left click, it should stop the movement and go into this currently empty state. Whenever you go to Unity, you pray that you don't have any errors or any bugs, and if you do, just look in your console to see what could be causing it. So now we should have a platform that spawns in and starts moving side to side. There we go. And if we look at, I didn't make this, I think I might have made the platform speed value yeah, there we go. So if we make it 0.1, notice how much slower it goes. If we put it to default speed, then that's the speed it's going to go. If we go bigger, it will go crazy speed. So 0.5 seems like a reasonable speed. So there we go. It's going to ping pong between the two values that I set. Earlier on, my value was -10 and 10. So -10 is where I start. And 10, because my level is designed around the center of the world, it was a safe assumption that the opposite of -10 in this world would have been 10, which it is. So I'm just telling it to move from -10 to 10 and then back again. So if we watch that again, that is exactly what it's doing. So phase 1 of our setup is good. There's our randomly new. Now if I left click, the object stops completely. Because now we should, because it's a kinematic, it's not dropping, so we need to do that. First thing we need to do is enable the kinematic to be true so it can drop down and then hit this platform. So let's get that section of the code working. So we're going to do it in here. So in here we're going to tell it that, sorry, rb dot, and then we're going to look for is kinematic is equal to true. And that's pretty much all we do in there. We're just saying when I click the button, set the kinematic to be true so that the object can drop. I just want to rename this one variable. Even the enum should be called the way I normally do my stuff, which is like that. It's just was distracting me a lot. So there we go. That's sorted that out. Okay, so let's test if that works. That should work without any issues. There's no reason why it shouldn't. So this bloody window. If you're wondering, I think I figured out why that window keeps popping up. If you go edit, go to preferences, and go to where it says general, recompile and continue playing. It's one of these. So I'm going to say recompile after finished playing, and then maybe that window will no longer pop up. Okay, sorry, I had to pause the video there for a second. We're back. Just got a random call. So let's try this again. Start the game, and now we're going to see if the platform drops when I click on it. It did not drop. Question is why it did not drop. We did say it to be true. Oh, of course. It can't be true. It needs to be false. What am I doing? What am I doing? What am I doing? Remember to save, and let's go back, and now it will work. I don't know what I was thinking. My brain was thinking the opposite. Like, yes, I want it to drop. Make it true. Okay, so let's do that, and there we go. It drops. And that's it. So now what we need to do is when it drops and it collides with a specific tag, I want to tell the spawner to spawn a new one. And if it collides with the kill area, I want the game to restart. So let's start by doing one section at a time. So we're going to go back to our code here, and we're going to, inside of, like outside of the update, we are going to add an onCollision enter 2D. And while we add it, we might as well add the onCollision, the onTrigger enter 2D. You could do both of them in the onCollision. I just like to do both just to kind of remind people that there is an onTrigger and an onCollision and how you can use them for different things. I normally use my onTrigger for pickups so that it doesn't slow my character down even for the briefest time, and I normally use onCollision for detecting and to getting more information like a hit point, that sort of thing. So it depends on what you need to use it for. Okay, so what are we doing on collision enter? We need to go ahead and create some tags quickly first. So I think I have them created, so we're just going to assign them. So I want the floor, my little ground, starting to be tagged as platform. There we go. And I also need to make sure that all my platforms are tagged as platform, which they are. Okay, and then my kills volume, oh, I've already done that. It's been assigned to a variable called kill volume. So I need to remember these names. So that one is called platform, spelled like that. Okay, so now we can go back into our code and do that. So inside here, we're going to say if. We're doing an if statement because we want to check to see if something is, if it's right. And if it is, and we're going to go other dot. Because it's a collider, you have to do GameObject first before you do the compare tag. So GameObject dot compare tag. And if you're wondering why I do compare tag other than doing other dot GameObject dot tag equals, because compare tag, as far as I understand, is it's a Unity specific thing, which means the performance of using this compare tag is cheaper than using the dot tag equals version. So in there, we are looking for platform. So if I hit the platform, I remember I've got that on collision boolean. We're going to set that to true because now that means we've actually collided with something. But I only want this to fire if the platform is platform and exclamation on collision. So if this object has never collided with anything, which means it will be false, and it is a platform, then, because if we don't put this kind of fail safe in here, if we don't put this double barrel if statement, as I like to call it, like you will end up having, every time that object collides with something, even the smallest amount of collision, it will spawn a platform. And trust me, when I was doing the prep for this video, I ended up with something like 150 platforms spawning all at once, which you can imagine Unity did not love it for any like extended period of time. So I just created a little fail-safe. So the first time this platform collides with something is when we're going to tell the spawner to actually spawn. After that, it can keep colliding, but it's not going to instantiate any more platforms. Okay, next step, we're going to go and say spawner dot, and I think we called it spawn platform. There we go. So this is where we tell it to spawn a new platform. And then we're going to add a little bit more code as we go for score and stuff in here. But right now, all we need is when this collides with that, it spawns a new thing. But we might as well go and do the onTrigger. So if, we're going to say other dot, this time it's just compare tag, because it doesn't need any information from the object. It just registers the collision. It doesn't actually register anything else, like any hit points or positions or normals or any of that stuff. So we're looking for, I think it's called kill volume. Is that what we called it? There we go. And if that's the case, we're just going to go scene management. Notice how it's not here, because remember, it is a namespace that we need to add the namespace at the top. So using Unity engine .scene management. Go down here. We start typing now. We're going to get scene manager .load scene. And what scene do we want to load? We want to go scene management .get active scene and get the build index. I always prefer build index to like strings. Strings, first of all, are more expensive, and the build index is like 0, 1, 2, 3, 4, 5. It's simpler for me. And all we're doing here is we're essentially, let me put a comment above this to tell it, we're put what you would like to happen in here. when the game is over. So this is what you want to put when the game is over. So you might want to call up a menu that pops up. They're saying, would you like to retry? Would you like to go back to the main menu? Maybe have the high score in that thing, that sort of stuff. I'm gonna have an entire video dedicated to taking one of these that I've done and showing how you would go about that. But right now, I just put in scene manager.load scene just so that it's easy for testing. So I just use this piece of code to test because all it does is reloads the level from scratch. Okay, so let's test if both of them work. So first, let's see if we can get a platform to spawn, and then the next one, can we get the level to restart? Okay, there we go. Instantiate and drop this one off the edge. There we go. Okay, so they're both working. So as long as we hit a platform, like we're doing there, whoa, that was close, we will always be spawning a platform. No, save it. No. Okay, so both of those systems are in place and they are working. So all we need to do now is just kind of add a little bit more to that. So I'm going to move on to doing the camera movement. So the camera will follow the stacking as it gets higher, but only when the stack reaches about the same height as where the camera is at the moment in the Y. And then I'm going to offset the camera by a certain amount up, and then wait for the platforms to reach that point again, and then move the camera up. So we're going to be doing that progressively up, and like only move the camera when it needs to be moved. So we're going to add a new script. Let me just move to my next part of my slides, my prep. I'm just going to open up that. Okay, and then we can go here. We're going to go into the script section and add a new script as soon as it works. We're going to call this stacking camera. Yeah, that's good. Stacking camera. And just, yeah, okay, that bolt thing did not get rectified by that issue. So I'm just going to grab my stacking camera script, drag it onto my camera, and then we're going to go in and just set the camera side of it up first. And then once we're done with that, we're just going to go into the actual, where the platforms themselves are going to be doing the comparison, and then update the camera to move. So we need the update. We do not need the start. So I'm going to remove all of that, and I'm going to add I'm making this public if you're wondering why, because later on if I want to speed the actually no, this doesn't need to be public, I lie. It's actually the platform speeds that should have been public, but okay. So it's serialized field, and this one's going to be our camera speed. So how fast our camera moves up. I think I'm going to set that to be like 2.5. Remember to put an F or you're going to get an error once you put in a decimal point. Next one is I need a boolean, so I'm going to make this can just be straight up. This actually does need to be public because I'm going to be talking to it from another script. This one's going to be bool, and this one's going to be can move. So I'm asking the camera, I'll move camera. There we go. Let's just do it like we did in Bolt. Camera move is going to be false, which means the camera can't move. And then the last one is we need again another public variable because I need to reference it from another script. And this is going to be new camera position. Might as well spell the whole word while we add it. Y, not T. Okay, so again, I only care about the Y position, so we're just going to let the camera get its current position from its own transform. The Y position is going to be updated based on that. And then the last one, this one can be serialized, and this one's going to be a float, and we're just going to call this camera. Let's call it offset Y. I'm just going to put again a default value here of 2, so it's going to be 2 units higher than where the platform was found, and we're going to use that offset value to allow the camera to go a little bit higher, so it's not just always in the center of the platform. Okay, I think that's it. And then move this one up just so that the serialized are together and the publics are together. And now inside we need to actually do the camera transform, but only if the boolean move camera is true. So only if we can move the camera, we are going to do a transform dot position is equal to, and again we need a new vector 3 because we don't care about anything other than the y position. So for the x, we're going to go transform dot position dot x, and the y is the important part. So we're going to do a lerp again, so math f dot lerp, and we're going to lerp from the current y position to the new position, which is our new camera position, that long one that I typed out, plus the offset. I think we called it new camera, we called it camera offset y, there we go. And then we're going to go comma, and the last thing we need is our camera speed. So camera speed multiplied by time dot delta, and that is basically our y. Then the last one is comma, we're going to go transform dot position dot z, and that's all we care about at the end. Okay, so that is our standard movement. If we look at it, our x stays as our camera x, at the end our z stays as our camera z. In here we're using a math f dot lerp. We're lerping from the current position to the offset position that we're giving it, our new position, plus the offset, multiplied by the speed that value that we've got, which is 2.5, multiplied by time dot delta time. So that's all we're doing in there. Okay, so we need this to stop. Whenever I put something in an update, I do not like having it firing unless it needs to. So imagine if we leave it as this, and once this goes true, or imagine if we just left it as it was. It would always be saying transform.position equals, and even if it's already at the same position, it's always updating that transform. I prefer to kind of only call this code when it needs to be called, and then that way free up some memory for other important stuff. So in here we're going to do an if statement, and we're going to check to see if our current transform dot position dot y is greater or equal to that. So what that means is it's going to see, okay, cool, by the way, is the camera reached its location, basically? Has it reached that new position yet? If it has, we're just going to say move cameras equal to false. So that's all we're doing there. We're just seeing if the current camera position has reached its new location or greater, and if it has, then set the camera move back to false. That's all we need in the camera. So if you're wondering, we haven't set this because we're setting it from somewhere else. So we're not setting it in this code. So let's go to the next stage, which is going to be going into the actual object code, which is our stacking platformer. That's where we're going to do the rest of the code. And we're doing it inside of the on collision. So on the collision, we're going to do an if statement. You could put it in the camera. I just felt like this was in my brain, the way I break things down is just like, who needs to be able to know this information, and who's got the information it needs to know. So the platformer knows where it's at, and it can compare itself to the camera, and then based on that, it can tell the camera whether it should move or not. And it was just made a little more sense. You could have put this if statement inside of the actual camera itself. That is up to you. So over here, we're going to do the exact same thing. We're going to go transform position dot y if this position of this object is greater or equal to, and we're going to go camera dot main dot transform dot position dot y. So earlier on, when I said I was going to create a camera variable, the reason I do that is, first of all, it's better coding practices, but right now I'm just actually finding the camera in the scene. So the trick is we're finding the camera in the scene every time. That's tagged as main, and we're finding its position. So again, probably let's actually just do that. Let me not be lazy. Let's go down here. Let's make this a private variable. Let's call this camera, and let's call this camera reference. Okay. And in order for this to work, in the start, we need to say camera reference is equal to find object of type camera. And if you want to, you can go .main. You should be able to. Hold on. Oh, wait. course. .main. That should work. Ah, well, screw you. There we go. That'll work. So now that we have a reference to the camera, because this will give you issues if you have multiple cameras. So actually, in this case, I won't search for the camera. I'll search for the stacking camera script. That'll make my life a lot easier in case I have them. And then after that, I'm going to go dot camera, dot get component camera. There we go. That way I'm getting the exact camera that I want based on the script that's on the camera. So now we can go there, go back down here, and remove all of this nonsense and just put that in there. Okay, so now that we have that, only when the transform position Y of the platform is equal to or greater than the current Y position of the camera, we are then going to say, tell the camera and we're going to go dot, yeah, that was stupid. Sorry, apologies for that. Let's rename this variable to not be a camera, but to be the stacking camera. It's just going to make, again, a lot more unnecessary code, and then all we need to do is just remove that part of the code and go down here. There we go. That'll work. Dot, and now we're going to be getting the, I think it was called new camera position. There we go. Is equal to, and what is it equal to? The new camera position is equal to this object's transform dot position dot y. So all we're telling the camera is, remember that variable called new camera position y? Please set that variable to be the transform dot position y of this object, and then in the camera it's going to say, okay, cool, get this position, add 2 to that position, and that's where the camera needs to move. And now we need to, after we've done that, we're going to go camera reference dot move camera is equal to true. So now we're telling that if statement, you can start calculating and firing off that logic or that code. Okay, so let's see if this works, shall we? Because all we have left after this is just adding the UI from a previous video tutorial and just feeding new information into that. Okay, so there's our camera positions in the middle of the screen. So basically somewhere in the middle over here. So we do expect the camera to move up by 2 units from that position when we get there. So watch the new camera position is Y. So every time we hit a platform down, it should update that value. It should have updated that value. Oh, it will only update that value when we actually get, there we go. So now we need to get to the middle of the screen again, which is right there. There we go, so that worked. It felt a little bit fast, so I'm going to make my camera speed something like 1.5. And we're going to try it one more time, but that worked really nicely. It moved up by, and maybe it needs to move up at a few more units. Maybe 2 units isn't enough, but whoa, I'm sucking already from the start. Boom, let's see, we're getting there, we're getting there. I think the next one should be the one that moves it. There we go. That was nice. It had a nice little ease in at the end and that sort of stuff. So there we go. Let's try to do it one more time. I think this should be the one that breaks it. There we go. Okay, so that's it. That was a pretty good game. I was doing quite well. So now all that's left to do is if you haven't watched the video, like one of my previous videos, I'm going to be creating a video just around systems and UI managers. So I'm going to just go to one of my previous ones. I think it was my Rising or something. There we go. I'm going to grab this coins canvas, go Control C, bring it into my stacking C# and just paste it in here. Also just going to make sure this was set correctly, like it should have been, 1920 by 1080. I'm going to just, there is a UI manager here that's got a text. So all I'm going to do is I'm going to make sure that my text, there's a few things that need to be tweaked. I'm not quite there yet as far as how I feel about the way this looks. So I'm also going to just reduce the font, maybe make it bold. change the color to match the color of this background plate here, and then I'm just going to move it up in the UI so that I can see it, so that the score in this case is inside of the platform there. There we go. I'm going to go and look at this code really quickly. I'm not going to go just to show you how it works. It's a UI manager. It's got a reference to the to itself, so it's so that other scripts can talk to it. This is another way to reference scripts. It's got a UI text reference. It's got a score total reference. There probably should be a high score one in here, which I'll expand upon. At the top, I had to use using Unity Engine.ui for this to work. And at the start, I update the UI score with a text field in the front here. So I think I'm going to replace this real quick with a serialized field. Let's call this string, and let's call this text formatter. I think I spelled that right. I sure as hell hope so. And text formatter is going to be replacing that. So in the editor, and depending on what game I'm building, I can change what it says. So instead of saying coins, in this case it's not going to be coins, I can choose what I wanted to say in front of the actual score. So now that that is done, we'll have a new variable that pops up on our UI manager in the script. In this case, I'm going to leave it blank. I'm not going to put anything in here. I just wanted to show. Actually, let's just call it platforms stacked. There we go. Let's see how that works. Let's just test to see if that shows up. It should say platform stacked 0. That is way too much text to fit in that small little area. So I think I'm going to need to change the font size one more time. Let's make it like 35 or 350. It's just not going to fit in that area at all. Okay, I don't want it to kind of, I guess it could be okay like that. Yeah, let's do it like that. Let's just leave it. Let's just reduce the font a small amount more. Maybe, and so that it can maybe be on the same line. Okay, there we go. Okay, so let's test to see how we're going to go about calling the manager. Remember, we have the script and here, and we're referencing it by UI manager over here by that. So inside of our stacking platforms, every time we successfully stack a platform, so on collision enter here, I'm just going to put it after the if statement. We're going to go and say, we're going to look for UI manager dot, remember it's underscore UI man dot, and we're going to say, I think it's UI update UI score. There we go. There we go. So now let's try and see how that looks when we're stacking our platforms. This bloody bolt window. Okay. So there we go. 0 platforms. When I touch this one, I should get 1. There we go. 2, 3, 4. And it keeps going up. So we're going to keep going till we mess up so you can see it, how it works. The camera's still working, which is always a good thing. Early on, I had some weird issues with the camera. I was like, what has happened here? No, I got to 13. Let's quickly do 14 before the game is over. There we go. So that's it. So that is my stacking mechanic tutorial for our casual game mechanics series. I hope you've enjoyed this. If you have any comments, please do. It's always good to get feedback. Until I see you next time, be safe and take care of yourselves. Bye-bye.